Hello everyone! Welcome! Today, we're exploring a key concept in infrared spectroscopy called vibrational coupling. Have you ever looked at an IR spectrum and seen two peaks where you expected only one? This strange behavior can often be explained by vibrational coupling. It's like the bonds in a molecule are communicating with each other. Let's break down what it is, how it works, and why it's so important for interpreting spectra. Think of two pendulums connected by a string. If you start one swinging, the other will soon start to move as well. Their motions become linked, or coupled. In molecules, the same thing happens with vibrating bonds. When two vibrations in a molecule interact, their individual frequencies change. This interaction is vibrational coupling. For this coupling to happen, a few conditions must be met. First, the vibrating groups must share a common atom. This atom acts as the bridge connecting them, just like the string between our pendulums. A great example is carbon dioxide, or CO2, where two carbon-oxygen double bonds are connected to the same central carbon atom. Second, the individual vibrations must have similar energies or frequencies. If their frequencies are very different, they won't interact effectively. They need to be in tune to couple. So, what is the result of this coupling? Instead of seeing two individual peaks at their original frequencies, we get two new peaks. One peak appears at a higher frequency. This is called the asymmetric stretch. In this mode, the bonds vibrate out of phase. As one bond stretches, the other one compresses. The second new peak appears at a lower frequency. This is the symmetric stretch. Here, the bonds vibrate in phase. They both stretch and compress at the same time, in unison. Let's look at some classic examples. Acid anhydrides are a perfect case. They have two carbonyl groups linked by an oxygen atom. Because of coupling, they don't show one C equals O peak. Instead, they show two distinct peaks, an asymmetric stretch around 1820 cm superscript 1 and a symmetric stretch around 1760 cm superscript 1. Seeing this pair of peaks is a dead giveaway for an anhydride. Another great example is a primary amine, which has an NH2 group. The two NH bonds are attached to the same nitrogen atom and have similar frequencies. They couple to produce two absorption bands, one symmetric and one asymmetric, in the NH stretching region. This is how we can easily distinguish a primary amine with its two peaks from a secondary amine, which has only one NH bond and thus only one peak. In summary, vibrational coupling is the interaction between two vibrating bonds that share a common atom and have similar frequencies. This interaction splits one expected signal into two new signals, a lower frequency symmetric stretch and a higher frequency asymmetric stretch. It's a fundamental concept that helps us identify specific functional groups and understand the rich detail within an IR spectrum. I really hope this explanation cleared things up for you. Thank you so much for watching. If you found this video useful, please hit the like button, subscribe for more chemistry content, and consider supporting the channel through the links in the description. Your support helps me create more educational videos. See you next time.